And in the case of this library, it's integrated within the MapReduce process. Okay, next one. So we're looking for the last example that we saw. The statistics measures are computed by which of the components? Okay, so it's in the reducer that everything is done. Yes. Okay. So last but not least, so the program of the word stats works for words in which type of input? Okay, in any textual document, it's not related to English because it just counts the tokens, in fact, and it provides statistics of the tokens. And it's not any document of any type because that would mean that we can put a blob or whatever and it would work, and this is not the case. And then it's not associated to a specific input, so this is why only the text in the Twinkle Toes mine is not a right answer. Okay. Okay, so we have the podium. Very good. So in any case, I think that things are going better. I think that while we have been discussing, I believe that things are getting in place in your minds, and this is important. Do you have questions or comments before we move to the second activity?
Yes, doctor. How are the points going to work, or how will it work then?
How are what?
Yeah. Like what's the actual, like, the winning prize of the Kahoot?
I mean, the challenge for the whole, the two activities is 10 points. Okay, so I'm going to rate the importance of the activities depending on how well you do.
Okay.
But the total, I mean, I'm not going to give to ponder something that where people didn't do very well, because otherwise I will kill everyone, and that's not the purpose. So now
Uh,
you have a result. Then in the next activity you will have another one, and I will have a look on the results, and out of them I will ponder the one that where you do best as preferable, and then the other less important. But in the whole for the whole two activities, you are challenging 10 points out of 25. So it's just a little piece of the whole grade for the partial two. Okay. Was my answer clear?
yes, doctor. Thank you.
Okay. Okay. You're welcome. Now, for the second activity, we are going to do the following. I'm going to give you, yes, 30 minutes. You can rest, I mean, keep the teams that you are working with. And we have in the, well, what you need is to open either the GitHub or the collab document that we have in the last lab. You need this, and what you're going to do, I'm going to distribute the. Sorry, I'm just having a lot of windows, and so share this. So the idea is that you are going to prepare 4 slides. You can use Google Slides to work on, and you are going. I'm going to write this in the on the chat. For the exercise that I will assign, you will have to explain the code and explaining the intent of the program, the principle of the solution, giving the code and the explanation of the code, explanation. And in the case you have combiners or reducers, explain. I mean, I'm gonna write here with combiners and reducers, explain how they optimize the task. And practitioners. And the examples with no combiners, then propose an optimization with combiners and or partitioners. Right, so this is what you have to prepare in a maximum 4 slides. It can be less. And then the exercise. So I'm going to put here if you don't have it in hand. So this is the GitHub that has the exercises. So we'll have 1, 2, 3, and 4. So, and do I have the teams? Yes, here are the teams. So the happy team will have exercise 6. Then the team exercise 1, I mean the example 3, the counting the number of lines in a file. Then the team X will have example 5, and Hack Aztecs will have example 4.
Doctor, could you repeat the code for
The task, yes. What you have to do is in 4 slides, you have to explain the code of the example, and in order to explain it, you have to explain the intent of the program, state the intent of the program, the principle of the solution, so you can copy paste pieces of code and explain the principle and how does it look like in the code. Then for the examples where there are explicit combiners and partitioners, you should explain how do they optimize the task. And for the examples, so 3 and 4 that do not have these combiners and partitioners, then propose an optimization with combiners and or partitioners. And that's it.
Yes, and could you just repeat the assignments of the, like, which team should do which code?
The happy team, I said that the last one, so it was exercise 6. Then team is exercise 1. Team 5 is, team X is example 5. And team Hashtags is 3.
Perfect. Thank you.
You're welcome. So I let you work. Then when you finish, please share the link of your Google Slides on the chat. And well, you will choose someone to, or you can, the 4 of you can give a round and explain your solution. Okay. Good.
All right. Thank you, Doctor.
You're welcome. So I'm going to shut the camera, but I have my mic open and I'm listening to you if you have questions.
but it's sweet.
Thank you. When I mean, all the teams will present the work, and I have shared an evaluation form. So the other teams must evaluate um, all the teams. So we have 4 teams, so you have to evaluate 3 teams every in total. And so you have to fill in 3 Google Forms, which for the teams that will present, that is not your team. And so we will use this to evaluate the work. And only one person, I mean, it's evaluation per team, so only one person of the team will answer. But of course, I will give you time to decide about the evaluation. We will start at 10 past 11.
So could you explain a little bit more because we're getting a little bit confused with the part that says with no combiner, then propose an optimization with combiner S and or partitioners.
Combiners, there's a supplementary space. Yes, two of the exercises, the 3 and 4, do not have neither combiners nor partitioners. So for those that are working on these two exercises, the idea is that you propose a strategy that could have both combiners and partitioners or only combiners.
Oh, okay. So then if our
Right.
program does have combiners, then we don't need to.
And then if your program does have combiners, then you have to explain how do these combiners and partitioners optimize the solution.
Oh, okay. Perfect.
Mm. So you have 4 minutes to wrap up, and we are starting with Team X. So we are going to start. I will let Team X share their screen, and if you can share the link to your slides on the chat, please. And the others, you have the Google Forms linked on the chat too, so that you can evaluate Team X.
Do we are screen, doctor?
Yes, please.
Okay.
Remember that it's an appreciation, so be fair. Nobody will get harmed by evaluations. Yes, please do share. The question is, I think that in the lab you are all presenters, no? You are all moderators even, so you can share your screen. Thank you, Mariana. Maria Fernanda. Please. Here. So do share your screen and explain what you did. You can either choose a speaker or you can just get a round robin the way you prefer. Run.
Okay. Hello, can you hear me?
Yes. Perfectly.
Okay, so, well, hello, we are Team X. We are Mauricio Raúl Tenorio Guzmán, Jorge André Tenorio Guzmán, María Fernanda Flores Luna, José Antonio Solís Martínez, and we're going to explain to you the example number 5, that is identifying the most used word.
Well, now explaining the intent of the program. Well, this intent is mainly about identifying the most used word in an input file, and this type of program is very helpful because it helps us understand how to use a multi-step job and not only one step like other previous examples. Because we in the first step we have a map, a combiner, and a reducer, and in the second step we only have the reducer. Well, and also one important aspect to indicate about the intent of the program is that there is a limitizer in the program that ensures that the words are not stop words, and meaning that there are no, it filters articles, prepositions, pronouns, conjugations, especially information that is not necessary for us to process as words.
Okay, now I'm gonna explain the first functions of the program. These functions are part of the preparation for the program, so there is no part of the map reduce here. The first function is the configure arcs, which is a function that configures the input, the execution call that we have to use in the command line to use the program. So it is changed to have the input file, the name of the input file as part of the execution code. And the second function is a mapper init, and it is a function that opens the stop words path. This stop words is a file, a file that is in the system file that contains the stop words that we want to avoid in the program.
Now, following the code, we have the mapper get words function, and this function obtains each word in the file that is not a stop word inside the stop word file, and returns the key value pair, word and one. And then we have the combiner count words. This function sums the words occurrences so far and returns the or yields the key value pair with word and the sum of the counts. Reducer count words is in this function we receive any key value, and a value which is a word count pair. And using the key and the max function, we find the most used word. In reducer find max words, in this function we receive a key values pair with count and word, and well, an instructor, and we return only the key value pair that has the maximum value of the pair. Finally, the function steps is the function in order in charge in charge of how the pipeline will be executed.
Okay, and finally, as we said before, we have one combiner in this code. This combiner is very simple. It sums the occurrence of each word and gives a key value pair of the word and the sum of the counts, that is the occurrence of the word, to the reducer. And this is an optimization because the reducer doesn't have to like aggregate all the words and their occurrence. It can just receive this key value pair and perform the built-in max function to find out what is the word that has the most occurrences. And yeah, that's pretty much everything for this example number 5.
Are there questions from the audience? No questions from the audience? Please? Are there any questions? No? All good. Okay. Thank you very much.
Thank you.
Thank you.
Now we go to Team Aztecs. So remember, you share on the chat the link to your Google Slides, and then you can share your screen. You have the rights to do that. Freddy, Carlos, Luis, David, Melina, Rodrigo. Please share the link of the Google Slides on the chat. Yes, please, Mauricio.
Teacher, I have a question. The forms is for us to
but not you, because you were the one that presented. The
okay.
other three teams will evaluate you, and now you will use a Google form to evaluate Team Aztecs.
Okay, and it's the same link, the forms that is.
Yes, yes,
Okay, thank you, teacher.
you're welcome.
Well, hello. We are Team Hashtags, and we are going to talk to you about the sample 4 that is about the grep. So the main intent of the program is to return all of the input lines matching a grep expression by using the exit status. So essentially what it does is that by making use of regular expressions, which is a pattern, grep can match a set of strings and return us all of these matching lines instead of matching words. It is minus e, that is going to take an expression given by the user. So another possible execution is the next one, when we apply when we are using the argument and also taking the text. Regarding to the mapper function, as we can see, we are going to return the command line, and it basically takes it is going to execute the bin sh type shell, given the argument minus e, that it is regarding that is going to be executing a program or a command from Linux. In this case, it's going to be grep minus e. That minus e is for pattern matching. Then we are going to evaluate what is going on with the grep command. In this case, if no matching lines are found, we are going to return an exit status of 1. And the next one.
and assigning them the value of 1. Then what we want to do is to reduce the amount of data that we have to process with the reducer. So what we are going to do is to add a combiner just to verify if there are similar sentences. In case we do have similar sentences, we will combine these results. And in this way, we're going to reduce the amount of lines that the reducer has to compare. And that's basically what our combiner would do to optimize our program.
Yes, and that would be all.
Okay. Questions from the audience? Sorry. Okay, so if there are no questions, thank you very much. And we move to the next team, the happy team. So Carlos, Armando, Alexander, Francisco.
Yes, hi, I'm going to be the one presenting.
Good. Remember to share your Google Slides. Thanks. So you can share your screen.
Ah, you cannot see it?
Mm-mm.
Okay, let me try it again.
Now it's gone. Right.
Okay, well, we're gonna be presenting example 6, which will be the statistics example. And we are team happy, because we're always happy.
If you're speaking, we cannot hear you.
Yes, we can hear you, Armando.
Yes, you're muted.
Well, I think he's having connectivity issues. Yes, he says he's gonna rejoin the session.
Yeah, coming back and forth. Okay. Maybe one of the others can start while Armando comes back.
Yes, well, our program, one of the intent of our program is to, for any word that appear in a document, compute the stats about which word come next. This program also include the use of combiners that we are going to see later. The next, please. Before to explain the code, we think that it's important to see the general pipeline that our program follows. Well, first to execute any function, we have the function steps that indicate which function go first and then. Well, in this case, we can see which functions have the combiner, that is the C combine counts, and the general functions, the further you can see. My partner Alexander are going to explain this function next.
Okay, so to define the program, the principle of the solution, we first begin by importing the necessary modules. From mrjob, we import mrjob and mrstep, which are respectively the base class for MapReduce jobs, as well as mrstep, which represents the steps that are handled by the script. We also are going to make use of regular expressions, which is why we import the RE module. Following, what we do is we define this new variable called word_RE, which is a regular expression pattern object, which will let us search for matches inside the different strings and using its methods. In this case, the pattern we want to match is with one or more, at least one word character, that consists of alphanumeric and alphanumeric characters and underscores, and the empty say like an empty character as well. Very well. We then define a new class called mrNextWordStats. Said class is a new job because it is importing from the MR job. It's inheriting, excuse me, from the MR job base class, which means that we can use the methods that define the steps of a job, be it mappers, combiners, or reducers. We define a constant called sort values, which equivalents to a true Boolean, and then we define the steps method. This steps method is necessary to be overridden from the base class MR job in order to define a list of steps that follow our program. In this case, we will return a list of MR steps that we define as a mapper, a combiner, and a reducer that will be defined in the m find words, c combine counts, and r sum counts functions respectively. And last, we'll reduce with the r compute stats method, which shall be defined in the following slide.
Yes, now here we have, well, as we mentioned, the steps of the pipeline. So we have the mapper, which is the function mFindWords, which tokenizes the lines and the four pairs of adjacent words. The combiner combine counts, which sums up all of these ones before passing the data off to the reducer. And then we have the reducer sum counts, which will compute the number of times each pair of word appears and the number of times that the first word in a pair appears and send it to the reducer. And finally, the final step of the pipeline will be another reducer step, which will be the computation of the statistics. And well, yes, this computation is part of the reducer. Then for each pair of words, it will compute how many times it appears, how many times the first word appears in a pair, and a percentage of times the second word follows the first. And well, this relies on the values appearing in certain order. Thus, we need the total number of times the first word will appear before we can actually compute the percentage of the second word. Now, we're going to talk a little bit about the combiner being used. Well, in this case, the combiner used is the function we named the program as C combine counts. And let me see, I think there was a message. Yeah, so basically, the combiner C combine counts is extremely useful, and it helps to summarize or condenses the map output records with the same key. And well, yeah, the combiner is basically the step that goes between, it's intermediary between the map step and the reducer step. And basically, it helps to reduce the volume of data transferred between the map and reduce functions. And well, this is very useful, especially because we have to consider that from the map stage, the output of the map stage is usually large in volume. So then, well, we could use this combiner, or a combiner could be used, in this case, for example, to sum up all these ones or all these outputs of the map stage in order to pass this summary or this like condensed data before passing it actually to the reducer. And well, it's very useful in order to maintain a lower a volume of data. And well, here on the left-hand side, we actually can see how it would work. So we have our mappers step, and then we will have our combiner, and then our reducer. And this will actually prevent the overhead or overload in the reducer following the mapper execution. And I think that will be it. Thank you.
Thank you. Questions from the audience? Okay, so if there are no questions, thank you very much. And now we go with the team.
Doctor, we're not going to evaluate our team.
No? Why? Why? No, I mean your own team, you don't. You only evaluate the other 3 teams that are not you. Right? So please go ahead.
Okay, hello everyone. We are the team formed by Fernando Nieto, Fernando Lopez, and Jose Mariano Portilla. And we are going to explain the example 3, the counting the number of lines of a file. Well, the intent of this example is, as its name says, count the number of lines in a txt file, like the example that of the twinkle toes that gave us. This is the text that Twinkle tool has, and the program will count the number of lines, that in this case is 10.
Well, now how the program works is the first part is the mapper, which reads each the line's profile and saves them in a tuple in the file path and the number one. And the reducer sums all these ones in the tuples and reduces them into one tuple with a total of the sum instead of one. For example, in the Twinkle Toes example, there are 10 lines, thus then will be Twinkle Toes with a 10. Next, please. And here is an example of the program running that was in the notebook, where we can see we put the input, which is all the documents in the docs to classify folder, and the Mr. Job program, which is the Python program for counting lines. And it says all the, for example, the first one, file path, blah, 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 and 33 lines, etc. Next, please.
So for the combiners, we decided to actually make the combiner the previous reducer. So we are summing the lines we've seen so far, and then in the reducer we are making a tuple of ones and path, so that next we can maybe find the max file with, I'm sorry, the file with the max lines, or the file with the minimum lines. I actually have and here is the output. We have the key as null and the value as a tuple, and I actually have the finished version. It is here. Here we are just making 2 more functions, the reducer max line and defining the steps. In the reducer max line, we are not caring about the key because we are yielding none in here, and we are finding the max lines, which are the ones. And in the steps function, we are just defining first that we need the mapper, the combiner, and the reducer pair. And then in the next step, we just use the max line reducer. And here in the output, we can see that we find if we run it again, we find that this file, the Chance Democratic Whitman America, has the most lines in the files that we input. That will be all.
Thank you very much. Please do share the link to your Google Slides on the chat so that I can keep track of them. Questions from the audience? Thank you. So I think that now we can say that you are touching MapReduce, right? and I'm happy about this. I'm happy about your job. So I will wait for the evaluations of the Google Forms, and I don't think that you have to worry about this part of the evaluation. And with this, we will stop doing anything to get points from MapReduce. Next lab, we will address Spark as another possibility of processing data in parallel. And I think that you have the basics about MapReduce. So I'm going to stop the session here because we are reaching the limit, and I believe that you have to go to your other classes. But I thank you very much for the work you did today.
Thank you, Doctor. Today's class was very enjoyable. I like the game.
Yeah. Great.
Thank you, Doctor.
Good. Have a nice day.
You too. Thank you, Doctor.
Bye, Doctor.
Bye-bye. Yes, nice week. We're starting the week. Nice week.